15.1, properties and operations. These are important. You're going to see them this year. You're going to see them next year. You're going to see them in Algebra 1. You're going to see them in Algebra 2. Okay? In advanced algebra. But let's talk about this for a moment. There's the commutative property for addition and multiplication, and the associative property for addition and multiplication. Now let me ask you something. Raise your hand if you've ever heard of the word commute. If you ever just heard the word commute, what does it mean, or what do you think it means, Kate?
To get from one place to another.
To get from one place to the other. And that's what this means. The numbers are getting from one place to another. They're moving, okay? Let me show you this. Let's take addition first. So let's say we've got 3 plus 2 plus 7. Can you tell me, what does that equal, Katia? 3 plus 2 plus 7. Let me get that out of the way. Does it equal 12? Is that right? Okay. Now, I'm going to move them around, okay? And let's say, how about 2 plus 7 plus 3? Okay. Now, what does that equal? Okay. So even though I moved them, even though they commuted from one place to the other, they still equal the same thing, right? That's what the commutative property of addition says. That if I'm adding things, I can move them all around, and I'm still going to get the same thing. Okay? Now, T. Let's talk about multiplication. How about 2 times 4 times, let's do it. Let's go 7. All right? Can you tell me what that equals? What's 2 times 4?
8.
Times 7?
56.
Great. Now, do you agree they're all being multiplied?
Mm-hmm.
All right, let's flip them around. Let's mix them up. How about 7 times 2 times 4? Okay? What's 7 times 2 equal?
14.
And 14 times 4. Do you happen to know that off the top of your head?
No, but it will equal 56.
But it's going to equal 56, isn't it? Because the commutative property of multiplication says, I don't care what order I do them in, I'm still going to get the same thing. I can move them around.
So it's like the addition.
Okay, it's like the addition. Okay? Now, let me show you this. T, great job. Katia, thank you, great job. Hank.
Yes.
Now let's talk about the associative property. In the associative, associate, who we hang out with. Okay? They're not going to move, they're just going to change groups. Watch. 2 plus 5 plus 9. Let's do those first. Right? I put parentheses around it. Sarah, what's 5 plus 9? 14 plus 2? 16. Okay. Now watch this, Sarah. I'm not going to change their order. That would be the commutative property. Their order is still the same. It's still 2 plus 5 plus 9, except now I'm going to do these two. Okay? So Sarah, what's 2 plus 5?
7.
Plus 9? 16. Right? That is the associative property of addition. The number 5 changed its association. Do you see that? First it was with 9, then it was with 2. It doesn't matter. I'm still going to get the same thing. Are you with me, Connor? Good, because you're going to help me with this next one.
Okay.
Now, Connor, I'm going to change. I'll go to green. Let's do 3 times 2 times 5. What do you get? What are you multiplying first?
2 and 5.
And what do you get?
10.
Times 3?
30.
Okay. Now, let's leave them in the same order, but we're going to change their association. Okay? Now what are you multiplying first?
3 and 2.
And what do you get?
6.
Times 5?
30.
Exactly. Same thing. That's the associative property of multiplication. Everybody happy with that?
Mm-hmm.
Good. Let me show you how it works with this first example. Okay? It is easy, but I want you to remember, because you need to be able to recognize it. That's the key. Bold. Example number 1 says you buy a portable CD player for $48. You don't. You get an iPad and, the gumball machine, an iPod. But anyway, you buy a portable CD player for $48, rechargeable batteries with a charger for $25, and a CD case for $12. It says find the total cost. Now don't find it for me yet. How would I find the total cost? What would you want me to do? Add them all up. 48 plus 25 plus 12, right? But now let me ask you something, Bolton. Looking at these three numbers, which ones would you like to add together first? Yeah. You would do 48 and 12, right? Why? It makes a clean number, doesn't it? Okay? So what is 48 plus 12, Bolton? 60 plus 25? $85, right? So that's our answer. But let me ask you this. Here's my real question. What property did this represent? Raise your hand. What property of the four properties did this represent? Matt? The commutative property of addition, right? Why was it commutative, Matt? You're exactly right. Why was it? The order was changed. We moved it. We took the 12 and put it there. The numbers moved. Okay? Not their association. All right? Good. Thank you, Bolton. Matt, great job. All right. Example number 2. Evaluate 4 times x times y. All right. Well, I definitely need parentheses, right? And for x, I'm going to put in -7. For y, I'm going to put in 25. But let me ask you something, Maddie. I've got 3 numbers that I'm multiplying.
Yes.
Which numbers would you like to multiply first?
I love to do 4 and -7.
Okay. Does anyone else see a different way that they would rather do it? Okay, Maddie, what do you think?
4 and 25.
But why 4 and 25? You're exactly right.
It's less to figure out. This -7 is have to figure out. And it gives you better.
I don't know about that. Katia, why do I want to multiply 4 times 25 instead of 4 times -7?
It's a
It is a cleaner number. What is it? It's 100, right? So what Katia and Maddie are saying is let's multiply 4 by 25 first and then by -7. Kate, what is 4 times 25? 100 times -7? -700. Beautiful. Perfect. What property did this represent? Connor?
Multiplication commutative.
Commutative property of multiplication. Yes, because we moved the 25. We put it in front of the -7. All right? Nice. Nice. Because the first few problems in the homework tonight, they're going to say, do this mentally, justify your answer. And when they say justify your answer, you're writing down what property you used to do it mentally.
So
See?
if you did the multiplication method.
Or the commutative or associative.
They tell you what, like, the
They don't. You have them in your notes. Good job. Now, let me ask you this. Who wants to simplify this first one for me? Is there anything I can do to simplify? Let's see. Sarah?
You get rid of x.
No. I can't get rid of x. I've got x plus 3 plus 6.
Oh no, you do 3 plus 6.
Sarah says she wants to put 3 and 6 together. So that's going to give us x
That would give you x, 7.
plus 9.
9.
Okay? 3 and 6 is 9. Let me ask you this, Hank. Can I put the x and the 9 together? No. They're not like terms. I can't put them together. I can't cancel it out. I'm done. That's as much as I can simplify. Okay? Devin. Second problem on this one. It says 4 times 8 times y. Okay? Now, Devin, can you multiply 8 times y right now? Do you know what y equals? Can you do anything with that? But can you simplify it?
Yeah.
What would you like to do?
Multiply 4 and 8.
So instead of this problem, you would like it to look like this. Right? Because you don't want to multiply 8 times y because you can't. You want to multiply 4 times 8. And what is 4 times 8?
4 4 times 8 would be 32.
32y. Good. Now, Devin, one last question. What did this problem represent for us? What property?
Multiplication.
It was multiplication, but what kind? What property of multiplication? Not distributive. We'll talk about distributive later. William T?
Associate.
The associative property of multiplication. Because they didn't change their order, did they? They didn't move at all. They just changed what they were associated with. The 8 was with the y, Maddie, but now the 8's with the 4. Okay, so it changed its association. It didn't change its order. Okay? Now, 2 more properties. These are easy. These are the properties. The identity property of addition and the identity property of multiplication. Okay? Now,
Oh, I see.
Hank, let me ask you this. What number can I add to a number and it stay the same? 0. 0 is called the additive identity. And it makes the identity property of addition possible. The identity property of addition just says, T, if I add 0 to a number, the number keeps its identity. Okay? Now let me ask you this. What can I multiply by a number and it stay the same? Maddie?
1.
1. 1 is the multiplicative identity. Meaning the identity property of multiplication basically says I can multiply anything I want by 1 and it just stays the same. Okay? Now, for this example, we're going to have to name the properties that this statement illustrates, okay? So look at this one. -5 times 1 equals -5. What property does that illustrate? What do you think? Sarah B?
Would it be identity?
It absolutely would be. The identity, and I'm abbreviating, guys, the identity property of multiplication. Okay. What about the next one? 2 plus -9 equals -9 plus 2. What property does that represent? Matt? The commutative property of what? Of addition, right? Because they changed order, they moved. Okay? What about the next one? Y squared plus 0 is y squared. Joanna? Awesome. Excellent. Right? Because we added 0 and it stayed the same. What about the last one? 2 times p times q is equal to 2 times p times q. Katia? The associative property of multiplication. Oh my goodness. LT. There we go. Can you read that, Connor?
No.
Okay, too bad. All right, here we go. Last one. Last one. Now this one, easy stuff. The Steel Dragon 2000 is the world's largest roller coasters. I love roller coasters.
Steel Dragon
Love
2000.
them.
Sounds very Asian.
Its length is 2,711 yards. How long is the roller coaster? In feet. What would I do to find out? Truman?
I multiply 2,711
By
by 3.
3. And what do I get?
Uh,
If you have it, raise your hand. You've got a calculator in front of you. Kate?
You have 8,000.
Oh, I'm sorry. I thought your hand. Yes, sir.
You have 8,133.
No.
No.
Sarah?
1,133. No, that's what he said.
Is that?
Okay.
Did you get it? 8,133? Is that right?
Yes.
Awesome.
Yes.
Good job, Truman. You did that in your head too, man. Well done. Okay?
Correct.
Because think about this. 2,711 yards, but what's a yard equal? Okay, well let me get rid of the yards and write 3 feet. Multiply them, and you get the answer. Done. All right. Oh, I got to stop now or it will throw this one away too. Good job, guys. You're ready. Get started on your work.